In August of 1984, NASA is ready to welcome a new member into its shuttle family. STS-41-D, the maiden voyage of the third orbiter and the 12th shuttle mission overall. Construction of Discovery started back before any shuttles were flying into space, in June of 1980. Built as the dedicated shuttle for launches from the West Coast from the U.S. Air Force, Discovery's California launches are canceled in the wake of the Challenger incident. Discovery departs the Dryden Research Flight Center one last time and piggybacks its way to the Kennedy Space Center. The crew for the first launch of Discovery consists of 1 shuttle veteran and 5 rookies. Mission Specialist 1 Richard Mullaney and Mission Specialist 2 Stephen Hawley are sitting left in the front row and will be overseeing satellite deployment. Commander Henry Hartsfeld and pilot Michael Coates are just to their right and will be maneuvering Discovery to the precise points it needs to be to drop off its record 3 onboard satellites aboard STS-41-D. And finally, Payload Specialist Charles Walker and Mission Specialist 3 Judith Resnick will be operating a prototype solar panel to be used in the construction of the upcoming Space Station Freedom, which eventually evolves into what is now the International Space Station. On her first flight, Discovery carries one of the heaviest payloads yet. On June 26, 1984, NASA begins the countdown to launch Discovery into space.
T-minus 31 seconds. We have a go for auto sequence start. Discovery's 4 redundant computers now taking over primary control of critical vehicle functions through liftoff. T-minus 15 seconds and counting. 10. We have a go for main engine start. 7, 6, 5. We have main engine start. We have a cutoff.
NTD, we have an RSO abort.
We have an abort by the onboard computers of the orbiter Discovery.
EPD verified the big monitor SRM ignition is safe. EPD verify that. Okay. Brake. PLS shows engine 1 not shut down. Okay, PLT. CFME, verify engine 1. Shut down engine 1. We did not show engine start on 1. OTC, CCME, I can verify push shut down and engine 1. No, we said start prep engine 1. Okay, are all engines shut down? You can verify that.
5 seconds prior to solid rocket motor ignition, Engine 1's redundancy gimbal system failed, prompting the master computer aboard Discovery to immediately scrub the launch. The astronauts evacuated the shuttle, and it was later determined that a stuck valve prevented the proper flow of liquid oxygen into the chamber, resulting in a much lower thrust than expected. The crew was safe, narrowly avoiding a hydrogen fire during evacuation. STS-41D's June launch attempt would be the first of many close calls during shuttle launches throughout the program. The mission was delayed a month to allow engineers to comb over the vehicle one final time and check for anything wrong. On August 30th, NASA tried once again.
T-minus 15. T-minus 11. 10. We have a go for main engine start. 6. We have main engine start. 3, 2, 1. We have SRB ignition and we have liftoff. Liftoff of mission 41D, the first flight of the orbiter Discovery, and the shuttle has cleared the tower.
Mission control confirms roll maneuver. Standing by throttle down to 65%. Begin passing through the period of maximum aerodynamic pressure. Throttling down in a 2-step fashion, first to 84%, then to 65%. seconds. Engine throttling back up. Throttling to 104%.
Houston, go and throttle up.
Discovery, roger, go, throttle up. Discovery given a go at throttle up, 1 minute, 30 seconds, velocity 3,400 feet per second.
After a long journey from a collection of jumbled materials on a factory floor, Discovery was finally in orbit. Hartsfeld and Coates made the proper maneuvers and prepared to jettison the first of 3 satellites, known as STS-D for the Satellite Business Systems Corporation. The crew watched as the clamshell doors opened and the satellite began to spin. After Resnick activated pyrotechnic charges located under the satellite, STS-D floated free from the shuttle. Its payload assist engine would kick it into a higher orbit approximately 40 minutes later. This deployment is filmed with the help of an onboard IMAX Cinema 360 camera identical to the one flown on STS-41-C. The crew of 6 then settle into the routine of spaceflight. Hawley demonstrates the use of an onboard tension treadmill that helps combat microgravity muscle atrophy. Coates and Mullaney are busy operating Discovery's onboard science experiments, which include the continuous flow electrophoresis system, flown for the first time with living human cells. This medical microgravity experiment dives into the prospect of creating better chemical medicines made only possible by prolonged weightlessness to combat ailments such as diabetes or osteoporosis. On the 3rd day, Discovery deploys the massive SYNCOM-4 satellite for the U.S. Navy. SYNCOM is a series of satellites designed to help the Navy steer its ships in the deep ocean with greater accuracy and predict storms, cyclones, and typhoons. The partnership between NASA and other branches of the U.S. government is strong thanks to the reliable capabilities of the shuttle. Missions like this may seem routine, but satellite deployment is one of the biggest funding attractors the shuttle has to offer.
One of the first that Henry mentioned was the fact that ours was the first flight to deploy 3 satellites, and here's the 3rd, the Telstar satellite for AT&T. And as with SBS, it was absolutely normal. There were no problems at all, and Mike and I felt very comfortable doing the task. One of the requirements we had was to film using the RMS wrist camera the burn of the perigee kick motor for all 3 satellites. And in a second, we'll show you the perigee kick motor burn for the AT&T satellite. Notice below on the ground the lightning in the clouds, and that was very noticeable, and we're glad we got it on tape to show you. There it is. And it was so dramatic at night that the lightning on the ground would light up the payload bay. And it took me at least several seconds to figure out exactly what it was that was causing the light. And there's the perigee kick motor ignition. In all cases, the motors burned exactly as predicted, and it's a fairly easy task for the crew.
With all 3 satellites deployed by day 4, the crew of STS-41-D could now focus on the task of testing the new OAST-1 prototype solar panel to be used on the upcoming space station. This solar panel comes in a box only 7 inches tall, but it folds out into a gigantic, magnificent wing that is 102 feet high, and it generates the same amount of electricity as one of Discovery's onboard hydrogen-powered fuel cells. It is the largest structure ever extended from a manned spacecraft.
The array unfolded just like an accordion being pulled up from the top by a coiled mast, which you can see in the front. The mast was made out of a fishing pole type fiberglass. And the blankets are pulled taut at two extension lengths, 70 feet and 100 feet. Here we have a scan from the aft window up out the overhead window, giving you some idea of how large the array really looked to us as we were doing work with it. While the array was extended, we used the small thrusters on the orbiter to try to excite the mast. We found it to be very stable, showing only small deflections that damped out very rapidly, and we were able to maneuver quite nicely to different attitudes with the array out. Here we're coming across Baja. One of the things that we noticed about the array was that it was translucent, so we could see both the sun and the Earth going by behind it as we were maneuvering. All in all, it was a good flight test for large space structures with potential future use in either space-based construction or in space station operations. And it's also a potential prototype of an inexpensive power source in both dollars and weight of the future for NASA.
After 6 busy and rewarding days, it was time for Discovery to go back home. STS-41-D initiated retrofire on September 5th and re-entered the Earth's atmosphere high over the Pacific Ocean, zooming in over Santa Barbara for an early morning landing on the long dirt runway number 22 at Edwards Air Force Base. The maiden voyage of a brand new spaceship could not have been more perfect. Discovery was quickly dusted off and mounted on the back of NASA's 747 for a quick flight back to Kennedy in preparation for its next mission. STS-41-D and the introduction of Discovery would both serve as a high moment for NASA. When every piece performed its function and every part performed its task, what NASA could achieve was limitless. Discovery represented the investment of the shuttle into the future of manned space travel, always pushing forward and testing new concepts in the name of knowledge, science, and discovery.